Will we ever shed light on the dark side of the universe? Guys, we don't have to beat ourselves up. We actually know a lot about the universe. We know, for example, that everything originated from a Big Bang about 13.7 billion years ago. We know that the universe expands, and for the past few years, we have also known how fast it expands and how it evolves over time. We've also understood many of the mechanisms behind its evolution, and we have been able to measure how much matter and how much energy is in the universe. These are absolutely amazing, extraordinary things, considering that our brains certainly did not evolve for this specific purpose. I would say that it is also quite amazing that in between the struggle for survival, we humans have managed to understand all these things. However, today I would like to tell you about the universe, one of the things that we still cannot fully understand. That is, I would like to tell you about its dark side, the dark side of the universe. There is a part of the universe that we don't see, that you can't see, and you can't see it because it is made of something that doesn't absorb light, doesn't emit light, doesn't reflect light, and actually not only light, but no other kind of electromagnetic radiation. So it would actually be more correct to talk about the transparent side of the universe. But to say dark, for us who grew up with Star Wars, is more ominous and therefore a little more effective as a term. In short, there is a component of the universe that we cannot normally see with telescopes. That is, with the instruments that astronomers have always used now for centuries to get a glimpse out there. Said in this way, it doesn't actually sound like such a dramatic thing. But try to reason about this. All the ordinary matter of which the universe is composed, and by ordinary I mean which is made up of atoms, you, me, the planets, the stars, the galaxy, is only a very small part, less than 5%, of all that is actually contained in the universe. The remaining 95%, so not a small part but the vast majority, is made of something about which we currently have no certainty. We're trying to figure out exactly what it is, but we don't know yet. And as an added complication, this is something that we have to try to understand. You can't see. It's absolutely transparent. It's a very frustrating situation. We're kind of like someone who wants to get an idea of what the Earth's surface looks like, only having pictures taken when the Earth is not directly illuminated by the sun. He would only see the lights of the city, but those lights would not reflect the distribution of the Earth's emerged surface. And more importantly, they would completely miss explaining the existence of all that darkness around them. Just as it happens to astronomers, who in the sky see only the stars, the things that emit light. On a day-to-day basis of those who study the workings of the universe is more or less like this. Of course, you're probably already asking the million-dollar question. If this thing cannot be seen, how do we know it's there? Well, this whole dark side of the universe thing actually started quite a while ago. In fact, the first person to use the term dark matter was the famous Fritz Zwicky, a rather difficult-minded astronomer who in the 1930s was trying to understand how galaxy clusters work dynamically. A galaxy, you know, is a collection of hundreds of billions of stars held together by gravity like our own Milky Way. Rarely do galaxies, if they stand alone, single and isolated from each other, but tend to form clusters of hundreds and thousands of individuals. And in the same way as a swarm of bees moving around a beehive, the galaxies also do not stand still relative to each other, but rather move chaotically around a common center of attraction, which is then nothing more than the center of gravitational field formed by the mass ensemble of the galaxies themselves. By measuring the speed with which the galaxies move, astronomers are able, using the simple formulas of Keplerian motion, to calculate the overall mass of the cluster. Remember, the same thing can be done with the solar system, so it becomes easy to calculate the mass of the sun by knowing the distance and speed of the planets circling it. Those closer to it are forced to spin faster than those farther away. However, Zwicky, who like everyone else at that time was unaware of the existence of dark matter, noticed in 1933 that the galaxies in the cluster in Bernice's Comma constellation were moving faster on average than they should be, just as if the total mass of the cluster was much greater than the theoretical mass. In short, there had to be a lot more matter and a lot more gravity in there to explain the agitated motion of those galaxies. Zwicky, who was Swiss-born and German-speaking, wrote that the galaxies must be held together by dunkle Materie, dark matter, but the idea in the 1930s was judged to be completely absurd and was shelved. Several decades passed, and in the 1970s it resurfaced thanks to the work of several astronomers, most notably American astronomer Vera Rubin, who was devoting herself to measuring the speed of stars in spiral galaxies, starting with the nearby Andromeda Galaxy. Vera expected to observe a rotational velocity of stars as a function of their distance from the center of the galaxy, similar to that of planets around the Sun, that is, as predicted by Kepler's and Newton's laws. Stars closer to the center would rotate with greater speed than those farther away. Yet the results were quite different. The outlying stars moved with the same speed as those located at the center of the galaxy. What Rubin discovered was that regardless of distance from the center, all stars had roughly the same speed. How was this possible? Was Newton a charlatan? Did the whole physics behind celestial mechanics need to be rewritten? Vera continued the measurements for a long time, observing hundreds of other galaxies, but the analyses of all the observations confirmed the same very strange gravitational anomaly. And this was absolutely baffling, astonishing. The astronomical community was forced to dust off Zwicky's conclusions and accept those of Vera Rubin, according to whom a huge mass of unobservable matter must exist around galaxies, forcing peripheral stars to orbit at higher velocities. Galaxies and clusters of galaxies would, in short, be at the center of a huge sphere of dark matter, whose job might be precisely to hold them together by preventing their disintegration. Our somewhat naive view of a universe composed of luminous objects is thus turned upside down. Luminous objects would be just tips of icebergs hiding large amounts of matter not directly observable. Nearly 50 years have passed since then, but to this day we still do not know what the nature of dark matter is or what it is made up of, although its existence has been confirmed by observations of very different phenomena. Yes, because the anomalous velocity of galaxies within clusters and stars within galaxies is not the only evidence for the existence of dark matter. Vera Rubin's was the breakthrough that rekindled interest in the 1970s, but since then evidence has come up galore. The most spectacular one goes back to a prediction that even Einstein made, namely the fact that light must also be affected by gravity, and that therefore light rays passing near a concentration of mass will be deflected by the gravity of that concentration. Therefore, if you put a certain concentration of mass between your telescope and the galaxy you are observing, for example a cluster of galaxies that completely hides the galaxy itself, what you should expect to observe is that the light bent by the strong gravitational field of the cluster will still bring you the image of the distant galaxy. Obviously, since the gravitational field of the cluster will almost always be shapeless and disturbed, the alignment between the galaxy, the cluster, and the observer will rarely be perfect, which will cause you to see it distorted, broken, amplified, multiplied, etc., etc., etc. What we can do, based on the amount of distortion in the images, is to calculate how much mass there must be in this cluster. And it is a huge amount. You could also see with the naked eye that these arcs are not centered on individual galaxies. They are centered on a larger structure. And this structure is the dark matter in which the cluster is immersed. This is the closest thing to really seeing with the naked eye at least the effects that dark matter can create. In short, as you're seeing, the sky is filled with mirages, stars appearing where they shouldn't be, images splitting several times, galaxies twisting and thinning like threads, as in a great kaleidoscope. But the illusions in this case are not created by sheets of glass or sheets of metal, but by the gravitational force of stars and galaxies. Because gravity also acts on light rays, deflecting and then concentrating them as a lens does. Did I say lens? And in fact, this phenomena is actually called a gravitational lens. We know of all kinds. The aspects that the object revealed by the mass takes on are virtually endless, and this video will certainly help you get an idea of what really happens when nature experiments in a laboratory the size of the universe. Wonderful, isn't it? But that still tells us nothing about whether or not dark matter exists. Now imagine that astronomers can observe a certain degree of distortion in images of distant galaxies, but with no trace of a mass in the light path between them and us to act as a gravitational lens. Wouldn't this be proof that the universe is permeated with lumps of matter completely undetectable to our instruments? And indeed, that is precisely what has happened, thanks in part to technology now so refined that we can detect signs of distortion even in images of galaxies that we have once have judged to be entirely correct. The universe is basically like an invisible, placid, rippling sea, giving us slightly distorted images of the fish we observe beneath its surface. But then, what is dark matter made of? There are many hypotheses, but no certainties. The most accepted theory is that it may be the lightest element of a family of particles still unknown to us. In fact, supersymmetric theories hypothesize that every elementary particle in our universe, quarks, electrons, photons, has a heavier twin yet unobserved. The lightest element in this new subatomic zoo might just be the dark matter candidate. This would be stable and could only interact faintly with our universe, making its search extremely difficult. That's not much, I grant you. What we have learned so far is certainly very puzzling. Is it possible that on one hand there is so much indirect evidence of dark matter, and on the other hand it is so difficult to reveal it experimentally and understand its nature? In fact, the situation now seems so strange that some scientists think that some other, even deeper problem may be hiding behind what we call dark matter. If we think about it, all the evidence for dark matter comes from astronomical observations, and all of it is based on the assumption of the absolute validity of the physics we know. But what if Newton's and Einstein's laws are not universally valid? What if gravity behaves differently than we think it does? These questions may be legitimate. General relativity has passed many tests and examinations. However, the absolute certainty of its universal validity on space-time scales, other than those used in tests to date, has not yet been achieved. For these reasons, an area of research has developed in which completely alternative theoretical scenarios are being studied, in which dark matter does not exist, and where the force of gravity acts differently from what we have learned so far. Under the umbrella of what is called modified gravity, a number of theories have been proposed in which Einstein's equations, or simply Newton's law of universal gravitation, are modified so that on scales known to us they reproduce known laws, but may have deviations when applied on a very large scale, such as galactic or cosmological scales. In short, the universe is a very strange place, and we are far from having cleared up its mysteries, especially what Albert Einstein considered the greatest of all, the one true mystery of the universe, its comprehensibility. How is it that the human mind understands it and can describe it perfectly with mathematics? Who knows if we will ever know. However, you should know that the dark side of the universe, invisible and utterly unknown, is celebrated on Halloween. In fact, October 31st is also the day chosen by physicists and astronomers around the world to celebrate Dark Matter Day.